Hello, so the 10 metrics that are proposed to evaluate whether or to assess the maintainability of a software system are presented here in this slide. And so the first one is the write short units of code. So what they do, they measure the number of lines of code, and then they try to find if each unit, they have small units, because of course if you have for instance a method has a few lines, it means that it's easier to read and to understand. So the same thing about write sample units of code. They look at the number of branching, and for instance, they try to see if you have less than 4 branches in your code, because it's easier to understand the code that have less sequences of if then else or cycles, or okay. So that's the type of complexity they measure here. Write code once, they look to find if you have code that is repeated. Keep a unit interface is small, they look at the signature of the methods and see the number of different parameters you have. And so the proposal, for instance, is that instead of having a method with 10 parameters, you create an object, and this object by itself contains these values. We have done this, for instance, with data transfer objects, where so that allows you to send more, and this is more maintainable in the sense that look, if you want to increase or decrease the number of values that you send by these through this interface, basically just change the object. So you only need to read or to change inside the object the parts that relate with the new information, or the information you just removed. So it doesn't change all the other methods that interact with this method that do not need to change. Another is separate concerns in in modules. So this is the single responsibility principle. Okay. And basically the idea is that you have small modules that focus on in only one responsibility. Of course, this is the point where things are interesting to discuss, in the sense, of course, this is a pure syntactic analysis. These metrics are pure syntactic, which means that, okay, if you have small modules, you can conclude that probably they have a single responsibility. It doesn't mean that bigger modules don't have a single responsibility, but I think that the point about using these metrics and looking at these is that basically it's just these metrics give you a perspective of looking at the system. But of course, this is just a value. Metrics are such as a value. What is relevant then is that you look at it. So the problem is that you have thousands of lines of code. The advantage of this kind of thing is that basically tells you or give you some hints about where to look for problems. And you may just look there and say, well, okay, I understand this, or say, oh, well, this probably needs this can be improved. Okay, so that was just a small remark about separate concerns in modules. Then a couple architecture components, loosely, basically depends on what one component exposes to the other. So they measure in the interactions between modules what is visible. So and basically they try to measure the encapsulation. Okay. Then you have keep architecture components balanced. So they look at different components, usually at several levels of depth, and try to see if they are balanced, basically. For instance, if all the components have the same amount of code. Again, is something that is a metric. So if you have a good value, there's a high probability. So if they are balanced, there's a high probability that it's relevant from the maintenance point of view. If they are not balanced, well, it's a sign, so it's an alert that you should look at it and see what's going, what really is doing there, what is really happening there, so that you can make your own opinion or evaluation about it. So keep your code base small. So that's another one that basically drives that's one they conclude that which makes sense. Okay, if you have less code, is easier to maintain, and this is something that I keep repeating you is what is difficult is not to write code. What is difficult is to have just the code you need to solve your problem. And so the idea that they have a small code bases, it's a very important point in terms of the maintainability of a software system. Then you have automate testing, and this, of course, they measure the coverage of your tests, and they use different metrics to evaluate how many lines of code you have for testing, how many lines of code you have for your source code. They compare it and they try to identify it. Okay, in terms of what is the percentage of test code. I think that they actually do not run the tests, so they just see the number of test codes, okay? Because that's a pure syntactic analysis of the system. And then you have write clean code, and here basically just look at some aspects of the code, probably close to what you do when you run some of the syntactic analyzers of the code that we have proposed you to use. And so they just see, for instance, if you have comments in the code, they notice and they inform you about it, and so try to find, for instance, that code, okay, that end code, so the code that is not invoked at all. So they do these inform about it. So this is something that if you run our tools that we just to verify if everything is okay, it's something that actually you will get a 5-year. Okay, so that's it. That's the ones, and then we'll apply this to our system and to see how our system performs in terms of these metrics. Okay, bye.